Good day, students. My name is Darlington. We shall be examining the concept of base and alkaline. Base and alkaline. Now, we are starting off with a base and alkaline. Base and alkaline. What is a base? A base is a substance formed when a metal excess bonds in air or oxygen. Example: magnesium in oxygen will give you white ashes of magnesium oxide. Zinc bonding in oxygen will give you zinc oxide. Aluminium in oxygen will give you aluminium oxide. All these are considered as bases. Now, note that some bases are not formed by the excess of the metal burning in air or oxygen. For example, sodium oxide is secured by heating sodium nitrite or sodium dioxonitrate 3 or sodium nitrate, IUPAC name, sodium trioxonitrate 5 with sodium. This is because when sodium burns in air, it forms a mixture of sodium peroxide and sodium oxide, from which it is difficult to recover the latter, which is sodium oxide, look as evident in the equation of reaction. Sodium bonds in oxygen to give you sodium peroxide, Na2O2, and as well as sodium plus oxygen giving you sodium oxide. So balance equation, put 2 here, this is 2, this 2, this 2, this 2 here. Oxygen to sodium 2. Sodium here is 1. Put 2 here, sodium here is 2, sodium here is 2. This man is 1, this man here is 2. Put half here. You understand? This is not the thermochemical equation. Therefore, we convert the fraction into what? Whole number. By multiplying all through by what? 2. Going to the what? The denominator. So multiply here, this will give us 4. This give you 1. This give you 2. So sodium here 4, sodium here 4. Oxygen here 2. Oxygen here what? 2. So now, sodium is not obtained like the previous procedure as specifically described. Therefore, to secure sodium oxide, sodium nitrite is heated with what? With excess sodium to give sodium what? To give sodium oxide. To give sodium oxide and nitrogen gas. So this will give you sodium here 2, sodium here 1 plus 1, 2. This is 2. Balance. Nitrogen here is 1. Nitrogen here is 1. Nitrogen here is 2. So we put 2 here. Nitrogen here is 2. Nitrogen here is 2. Sodium here is 2. Plus 1 here. If we put 2 here, we put 4 here. Now, nitrogen here is 2. Here is 2. Oxygen here is 4. Oxygen here is what? 4. Now, let's come to sodium. 4, balance. 2 times 2, 4. Nitrogen here is 2. Nitrogen here is 2. Sodium on the product side is 8. Now sodium here is 2 times 3 here. 2 times 1, 2. Plus 1, 3. So that is not balanced. All we just need to do is, since we are looking for what? 8. We just put a 6 here. So when we put a 6, this is 6 plus 2 here, 8. Y here is 8. So sodium is obtained, sodium oxide is obtained by heating sodium nitrite with what? With excess of sodium to give you sodium oxide. Do you understand? Some may say by heating sodium in insufficient air. But the question is, how do you determine that the air is insufficient? Do you understand? So the simple way to obtain sodium oxide is by heating sodium nitrite. That is sodium that we are heating with excess of what? Sodium to give you sodium oxide. Now, that is for base. Now, what is alkaline? What is alkaline? An alkaline is a soluble base that dissolves readily in water to furnish or liberate hydroxide ion. Now, alkaline, like acid, can be categorized into two groups based on their what? Relative strength. Alkaline may be grouped, namely, strong alkaline. Strong what? Alkaline. And what is strong alkaline? Ionized completely in water to furnish hydroxide what? To furnish hydroxyl ion. Now, example of strong alkaline. You know, sometimes when students are inquired to list strong alkaline, they always find it difficult to rattle off. Now, a simple key point, a simple key note that will enable you rattle off what strong alkaline is simply just to say hydroxide of group 1 what? A. Hydroxide of group 1A elements. Hydroxide of group 1A. Please note, don't just state hydroxide of group 1A. This is only spelled out to enable you rattle off and as well as remember with ease. But when asked, you should know this mentally. You should be able to realize this virtually and then write out the members. Now, of course, you know the members of group 1, lithium, sodium, potassium, calcium. So which means examples of strong alkaline, lithium what? Hydroxide, comma, sodium hydroxide, comma, potassium hydroxide, and calcium hydroxide. This is the reason the group 1 elements are otherwise designated as alkaline metals. So which means their base will dissolve in water to give you alkaline, as exemplified below. Sodium oxide dissolved in what? In water. Now look at this. This is HOH. Water is HOH. So this oxygen attached to this man, you have 2 sodium what? Hydroxide. You have 2 hydroxide to what? 2 sodium. So sodium here is 2, sodium here is 2. Oxygen here 1, 1, 2. This is 2, hydrogen 2, hydrogen 2. But then we have the other which is potassium oxide. Potassium oxide dissolves in water to furnish or produce potassium what? Hydroxide, which is good to hear. The question is what is balanced. So calcium oxide. Calcium oxide, this is calcium oxide. Calcium oxide dissolves in water to give you calcium what? Hydroxide. To give you calcium hydroxide. So calcium 2, oxygen 1, 1, 2, 2, hydrogen 2, hydrogen 2. So these are examples of strong alkaline. Hydroxide of group 1A elements. So these are hosts of strong what? Alkaline. The second category of alkaline based on strength, just like acid, as we learned in the preceding lesson, is weak alkaline. Weak alkaline. Now, weak alkaline ionizes incompletely or partially in water or aqueous medium to liberate hydroxide ion. Example: hydroxide ion of group 1 what? Group 1A, group 1A, group 3A, and members and few members of outer transition what? Elements. That is D block what? Series. You know, we have what is known as outer transition and inner transition. The outer transition elements comprises D block series, while the inner transition, it comprises the F block series. That is the lanthanum or lanthanide and the actinum or actinide series, which is situated or localized at the base of the periodic table. So, example, this is a keynote that whenever you rattle off examples of what? Weak alkaline. Examples of this. You know your group, sorry, this is group 2A, please, not group 1. Now, hydroxide of what? Group 2. You know this, calcium what? Hydroxide. Magnesium hydroxide. You know this. Your group 3, aluminium hydroxide. Aluminium what? Hydroxide. Then few members of outer transition elements. What are the few members? Zinc hydroxide, zinc hydroxide, zinc hydroxide, iron 3 hydroxide. Then we talk about copper hydroxide. All these exemplify weak alkaline. Now that is weak alkaline. Examples and the definition. Then we'll proceed to address acidity of a base, acidity of alkaline, acidity or hydrosity, acidity or hydrosity of what? Of alkaline, acidity or hydrosity of alkaline. What is meant by the expression acidity or hydrosity of an alkaline? Acidity or hydrosity of an alkaline is spoken of as the number of hydroxide ion which one molecule of an alkaline would relinquish if introduced in aqueous matrix or water. When I say aqueous matrix, I'm talking about water. So the number of hydroxide ion which one mole of an alkaline would relinquish or give up in aqueous matrix is designated as acidity or hydrosity of alkaline. Remember, we have that word basicity for acid, basicity or proticity for base for acid. The same way, in the same likewise manner, we are employing the term acidity of what? Alkaline. Now, I'm going to give you an example. I'm going to summarize the whole information in the form of a table. So this is going to be alkaline and what? Hydrosity. Alkaline and what? Hydrosity. Now, for sodium hydroxide is said to be monoacid. Monoacid is said to be monacid or monohydrosic. Then calcium hydroxide is said to be diacid. It's said to be what? Diacid or dihydrosic alkaline. Aluminium hydroxide is said to be triacid. It's said to be triacid alkaline or trihydrosic alkaline. Trihydrosic what? Trihydrosic alkaline. So here it is this man is regarded, sodium hydroxide is regarded as monoacid alkaline or monohydrosic alkaline, courtesy of the fact that it will relinquish one hydroxide ion if introduced in aqueous matrix. Now, this species is also considered as diacid alkaline or dihydrosic alkaline by virtue of the fact that it would liberate two hydroxide ion as evident in its molecular formula. You can have the OH in parentheses and 2 written outside and below to the right of the parentheses. Then we have aluminum hydroxide regarded as triacid alkaline or trihydrosic alkaline. Why? This is so named by virtue of the fact that it would liberate 3 hydroxide ion in water. As a consequence, it is called triacid or trihydrosic what? Alkaline. As you can see in the subscript written below and to the right of the parentheses. So that is called hydrosity or acidity of alkaline. Then the next one, now we'll look at the next concept, which is referred to as properties. Properties of what? Properties of alkaline. Properties of alkaline. Under this we shall be looking at physical. Now the first one, aqueous solutions. Aqueous solutions of alkaline have pH greater than 7. As we have learned in the preceding section on acid, that aqueous solution of acid has pH less than 7. Conversely, aqueous solution of alkaline have pH greater than 7. Number 2, the concentrated form of strong alkaline, such as sodium hydroxide, potassium hydroxide, and calcium hydroxide, is potentially caustic. What is meant by the word caustic? When we say corrosive, corrosive means that acid. We use the word corrosive about acid. The word corrosive is used about acid. The word caustic is used about alkaline. Now, what is the discrepancy between the word corrosive and caustic? Now, look at it. corrosive simply connotes that the burn of the skin is initiated by a loss of water from the underlying layer of the skin. That means the skin loses water. As a consequence, it shrinks and eventually peel off. Now, why caustic? Caustic means that the keratin, which is a fibrous protein that accounts for the firmness or toughness of the skin, is completely dissolved. As a consequence, rendering the skin soft and dissolving it into a pasty-like mass. That is what is meant by the word caustic. So, in a nutshell or in a laconic sense, corrosive means the burn is initiated by a loss of water, bringing about excessive shrinkage of the skin, leading to what? Inflammation. The white caustic simply means that it dissolves the keratin, a fibrous protein that accounts for the firmness of the skin. So, the strong form, the concentrated form of strong alkaline, such as calcium hydroxide, CSOH, please, not calcium hydroxide. As you can see, calcium is good too, and that was delineated as an example of weak alkaline. So, calcium hydroxide, sodium hydroxide, and potassium hydroxide is potentially caustic. And 2, their aqueous solution has pH greater than 7. 3, they have a soapy feel. They have a soapy feel and a bitter taste. When you touch alkaline, they are always very slippery to the touch, and as well as when tasted, they have a bitter taste. Do you understand? And finally, they turn red litmus blue. They turn red litmus blue. Those are the physical properties. Then we talk about the chemical properties. Chemical what? Chemical properties. Number 1, action of what? Acid. That is neutralization reaction. Neutralization reaction can be defined as a reaction involving the combination of hydrogen ion from an acid and hydroxide ion from an alkaline to form water as the only product. However, alkaline reacts with what? With acid to form salt and water. So acid plus alkaline to yield salt plus water. Now, example gratia, tetraoxosulfuric acid or sulfuric acid plus sodium hydroxide. This yields sodium tetraoxosulfuric plus what? Water. Another example is trioxonitrate 5 acid, old name nitric acid plus potassium hydroxide, giving you potassium triosonitrate 5. So that is potassium nitrate plus what? Water. Now, so these are the examples of neutralization reaction, action of what? Acid. So now, if you write this ionically, when this equation is written ionically, what do we have? But before you can write an equation ionically, you must ensure that the equation is accurately written and balanced. So let's ascertain that simple fact. Hydrogen here is 2 plus 2 here 4. Hydrogen here is 2, not balanced. So place a coefficient of 2 in front of water. So this is 2 times 2, 4. This is 4 here, 2, 2, 4, balanced. Sulfur here is 1, sulfur here is 1. Now, oxygen here is 4 plus 2. Oxygen here is 4 plus this is 1 times 2. That is 6 altogether. This is 4, 2, 6. Sodium here is 2, sodium here is 2. So the equation is balanced. Look at the second equation. Hydrogen here 1, hydrogen here is 2. Hydrogen here is 1 plus 1, 2, balanced. Nitrogen here is 1, nitrogen here is 1, balanced. Oxygen here is 3. This is 1, 4, 3 plus 1, 4. So I'm picking the first equation as an example to illustrate writing ionic equation. Now the first thing we need to do is indicate the state of matter. Aqueous, liquid. Now, substances in aqueous solution or that are soluble in water tends to dissociate, but insoluble substance remain in situ as the molecule. That is, insoluble substance retain the structural integrity or homogeneity of the species. Which means that, for example, silver chloride when dissolved in water do not dissociate, although the dissociation is infinitesimal, that is very, very tiny. So in that case, we will assume that it does not dissociate, since the dissociation is very, very tiny or immeasurable. So in that case, silver chloride now, being an insoluble substance, will remain in situ, that is undissociated. So in that case, one of the rules in writing an equation is that 1. Soluble substances or substance in aqueous solution dissociate into their respective ions. However, water, insoluble substances remain in situ. So in that case, H2SO4 is aqueous, as you can see from the state symbol. So it will dissociate to give you 2 hydrogen ion and tetraoxo6 ion. So plus sodium hydroxide is aqueous and as well as it's very soluble. So it will dissociate. This is 2 sodium ion plus 2 hydroxide ions, giving you sodium tetraoxo6 is a soluble salt, so it will dissociate. So that will give you 2 sodium ion and 2 sulfate plus 2 sulfate ion plus water. Water is liquid, it does not dissociate. Water retains its molecular homogeneity or molecular integrity. In view of that, water remains in situ, as I have stated previously. So this is liquid. So water retains its structural integrity. So now, the second rule is cancel out of the equation any substance that appear on both sides of the equation. That is, cancel out of the equation any similar species occurring on both sides of the equation. Now, as evident in the equation of reaction written on the board, we have 2 mole of hydrogen ion on the left hand side. On my right hand side, we are devoid of a hydrogen ion. So that means this hydrogen ion here remains. It retains its position. It is not cancelled out. This is tetraoxo6 ion. We have 1 mole of tetraoxo6 ion here. We have 2 mole of tetraoxo6 ion here. Sorry, this is supposed to be 1. This is 1 tetraoxo6 ion. So we have 1 tetraoxo6 ion. We have 1 tetraoxo6 ion. So since there is appearance of 2 similar species on either side of the equation, they cancel out. This cancel out, this cancel out. Now, we have 2 mole of sodium ion here. We have 2 mole of sodium ion. Similar substance appearing on both sides of the equation. This cancel out, this cancel out. We have 2 mole of hydroxide ion, but on the right hand side, we are lacking in hydroxide ion. Therefore, the hydroxide ion here remains intact. Water, we have water on the right hand side, on the product side, but there is deficiency of water on the left hand side, the reactant side. What does that connote? That means water will retain its position. It is not cancelled out. So in overall, we have actually 2 mole of what? Hydrogen ion plus 2 mole of hydroxide ion to give you 2 mole of liquid water. This is aqueous. This is what? Aqueous. We could make an intriguing deduction from this equation. And what is that equation? For hydrogen ion to be left behind, for hydroxide ion here to remain intact, and as well as for water, on the other hand, to remain in situ on the product side, it simply suggests the fact that hydrogen and hydroxide ion are the principal or active ingredient participating in neutralization reaction. As a consequence, it is more appropriate and precise to define neutralization reaction as the reaction between hydrogen ion from an acid and hydroxide ion from an alkaline to form water, not the reaction between acid and base, which is the conventional and as well as erroneous definition of acid, that of neutralization. That neutralization is defined as the reaction between acid and water to the reaction between acid and alkaline to form salt and water. That is no longer acceptable. That is, although it can be designated as a conventional but erroneous definition, very wrong definition. So the right one is the reaction between hydrogen ion from an acid and hydrogen ion from an alkaline to form water. You can probably ask this very strange or bizarre question. When you perform titration, do you really see the salt? No. The only thing you see is just water. So which means that the salt has dissociated in the water. So what you see, what is ocular visible to the eye is what? Is water. Which means water is the what? Is the product formed. Due to the combination of fusion of hydrogen ion and what? Hydroxide ion. So in that case, that is from triazole. Then this last chemical property is action of ammonium what? Ammonium salt. This reaction is exclusively used as a test for ammonium what? Salt. In that, ammonium salt, when treated with alkaline and then subsequently exposed to heating, tends to liberate a colorless gas with a characteristic choking smell. And this gas, by way of confirmation, is regarded as ammonia. So this is the reaction. A general reaction that will enable you to rattle off the equation if inquired. Hydroxide ion plus ammonium what? Ion. Now look at the mechanism of the reaction. Look at the simple mechanism which I propose. Now remove one hydrogen ion from here, add it to this now. What do we have? We have it with H2 what? O plus, remember, one hydrogen has been removed from here. We are left with what? NH what? NH3. So this is the gas we are talking about, a colorless gas with a characteristic choking smell. So when alkaline is treated with ammonium salt and then heated, a colorless gas with characteristic choking smell confirmed to ammonia is liberated. So a general equation is hydroxide ion. Use any alkaline. For example, calcium what? Hydroxide plus what? Ammonium what? Chloride. Now calcium and chlorine will combine to give you calcium what? Chloride plus hydroxide ion and one hydrogen ion will combine to give you water and what? Ammonia. So this reaction is exclusive to the qualitative analysis of ammonium salt. That literally it means the reaction is used to test for presence of what? Ammonium salt. In that, this gas is liberated which has a choking smell.